Let's imagine a scenario where you're building an app that aggregates users' data from multiple places. For example, a finance app aggregating the users' transactions from all the different banking services that they use. The first challenge in an app like this would be how can we access the users' data from all the different banking services in a secure way where it also doesn't ask the user to constantly give us permission to the different data. And if you've already tried to make an integration like this before, you've probably come across this illustration. This illustration shows the OAuth2 flow. And when I looked at this illustration for the first time, I was feeling overwhelmed and very confused. I wasn't sure what all the lines are, how many times we need to communicate with the API just to grab some users' data. But after a couple of years of working with OAuth2, now I understand the whole flow and I understand why some of the decisions were made. When I first used the OAuth2 integration, I wanted to integrate with Spotify to grab the user's data to use it in my app. And I followed their API documentation, and with some trial and error I managed to do it, but I didn't really understand what's going on behind the scenes. Now to really understand this flow, we need to understand the three key players in the scenario. Like you saw in the illustration, we have the application, the API, and the user. And all the communication happens between these three entities. And if you look from a bird's eye view, there are three main steps that happen between these three entities. We get an authorization grant, we get an access token, and we get the data that we want to get. Now let's go back to that illustration and go deeper into each of these steps. If we go back to the example from the beginning, where we're building a finance app to access the user's transaction from different banking services, the very first thing that needs to happen is our app needs to ask for permission to access the user's data from the API. And this is called getting the authorization grant. Now when the API gets a request like this, they will ask the user whether my app can access the data. Once the user authorizes this, the API will respond back with the authorization grant. So at this point, we haven't actually gotten any data yet. We've only gotten permission to request that data. And the next step that happens is our application needs to ask for access token and send the authorization grant in that request. And now the communication only happens between our application and the API. So if the API gets a request with a valid authorization grant, that means the user has already granted the permission to access the data, and the API returns back with an access token. Now we can use this access token to request the data we want to get. So at this point, the application makes another request to the API, but this time it doesn't go to the API authorization resource, it goes to the API data resource. This is where all the data is being kept of the user. So far, we've only communicated with the API authorization resource, which means authorizing the application to access the data. So now the next step is making a request to get the user's data, and we need to send the access token in that request. This way the API knows that we have a valid access token and we have permission to access the data, and they will respond with the data. And now our application can use this data, for example a transaction, and show them to the user in our application. So let's look at this from the perspective of the API. So if I have an API that I have users' data, I don't want anyone to be able to access this data. I want this data to only be accessible to my users and whatever they decide they can give the data to. So every time anyone makes a request to get the data from our API, we would authenticate the request and make sure that they actually have access to the data, whether that's the user or a third-party app acting on behalf of our user. So if we just imagine that we're given an access token that the application can use forever, that means they can access the user's data whenever they want, right? That means that if the application is compromised or this access token is compromised, that anyone can access the user's data. So that is why we add an expiration date to the access token. And usually this lasts for seconds or minutes. So now you might be wondering what happens after the access token expires. And this is where refresh tokens come into play. Refresh tokens are very similar to access token, but their expiration is a lot longer than the access token. They can last for hours or days. And the way we use refresh tokens is basically to ask the API for a new access token without prompting the user to give access again. And whenever we do that, the API still makes sure that we still have access to the authorization grant, and they can either reject or provide a new access token. There's also a lot more nuance on what type of authorization grants we can get. For example, when we get an authorization token, we need to provide a scope to which properties we can get access to. Whenever you log in with any social media to any websites, they'll ask if they can use your profile picture and name, for example. So this is basically what the scope is. You give access only to certain things, not the whole profile and not the whole data. Another big thing with this flow is that the user can revoke access to any application whenever they want. And the API, if they realize that the refresh tokens or the authorization grant has been compromised, they can also revoke access, which means that they can keep the data more secure. Now, of course, this feels very complicated and maybe sometimes it feels it's not necessary, but as the internet has grown and the technology has improved, so have the skills of the hackers. And with every new security measure that comes up, there's always going to be people trying to break that, either for malicious things or white hat hacking or whatever you want to call it. But the point is, our data needs to stay secure, and we trust these applications more and more each day with our data. We wouldn't want anyone accessing our transactions or private messages or emails or anything like that. That is why things like this still exist. And that probably in the future is going to be more and more complicated flows than this. And of course, the OAuth2 flow is not perfect. Like anything, it has its own drawbacks. Like I already mentioned, it is complicated, and if you're implementing this from scratch, it can be complicated. Most of the applications already have an SDK, which means that if you want to get data from Spotify, you can get the Spotify SDK for whatever language you're using and not really worry about this flow, but the SDK will get an access token, get a refresh token, and whatever it needs. And that's basically what I've done in the past, hence using this flow, but without actually realizing that I'm using this flow. But the more we understand how things work, the more we can see where things might go wrong or implement things around them so to make them even that more secure. And another big drawback of using this flow, I think with any flow, is if those access tokens or refresh tokens get leaked, it will take some time until the API or the user realizes and it revokes the access. This means that for a short period of time, it can be from a few seconds to minutes or even days until someone realizes that our data is being accessed in a malicious way. The hackers can still access the data. But I think that goes with all the current flows out there. Like I said, you can add more measures on how are the access tokens transferred. Obviously, you want to use HTTPS, and you can find a lot more things to improve this flow. But for now, I hope this gives more clarity on how the OAuth2 flow works. And that's been it for this video. Thank you very much for watching. Hope you liked it. If you have any feedback, put down in the comments. I go through all the comments on my videos. Happy coding. Bye.